Now after we have obtained K2MnO4 from the above reactions, that is MnO2 reacted with KOH and oxygen or KClO3 or KNO3, we are now going to convert K2MnO4 into KMnO4. The best method is by electrolysis of the alkaline solution obtained in above step. Here nickel anode is used, steel cathode is used. The electrolyte consists of K2MnO4 and water. The dissociation is shown as given in the reaction. At anode K2MnO4 is going to form KMnO4, give out one electron and form one K plus ion. Further, at anode we also see that the OH ions formed from water is going to form oxygen and give out 2 electrons. So this OH ion now reacts with the K plus ion and gives KOH. What happens at the cathode? At the cathode we are going to have H and H giving you H2 because OH has already been used by K plus, and that K plus has gone into the cathodic chamber to give me KOH. So at anode we basically had two reactions. One is formation of KMnO4 from K2MnO4 and the second one is formation of oxygen from your OH ions. That's all. At cathode there was liberation of hydrogen and formation of KOH. Now we go to the properties of KMnO4. We know KMnO4 is a dark purple colored solid and it is readily soluble in water. It has a melting point of 240 degrees Celsius, crystalline in nature and orthorhombic crystal structure, where A is not equal to B is not equal to C, that is a parameter of the crystal system. The manganese you can see is surrounded by 4 oxygen atoms. Here is the manganese in purple color and the average distance is the MnO bond 1.59 angstrom. The arrangement is almost a regular tetrahedron. Next we see how MnO4 looks like. It has got that Mn has got 7 bonds with oxygen, 3 double bonds and 1 single bond, and it carries a minus charge. So KMnO4 is formed by the ionic bond between O minus and K plus. Oxidation state of Mn is +7. This is a tetrahedral structure. Now the question comes, what makes KMnO4 a good oxidizing agent? We can see here Mn has got 4 oxygen atoms bonded to it and Mn is wanting to gain 7 electrons because it has already lost the 7 electrons to the 3 oxygen atoms by forming double bonds, and to one more oxygen atom it has given its electron and formed a single bond. Now it has got empty orbitals. It wants to regain its half-filled d orbital stability. So it will compel other atoms to lose their electrons. In the process it will oxidize them and itself get reduced. So MnO4 you can say acts as a good oxidizing agent only and not as a reducing agent because it has got no more electrons to give after it has given the 7 electrons to the oxygen atoms. So the final conclusion is what then? That a metal ion in a high oxidation state is more electronegative and acts as a good oxidizing agent, and it will readily reduce itself and accept electrons from other atoms. Generally, bonding with oxygen atoms and F atoms in high oxidation state is observed. What about the chemical properties? In the chemical properties, we know that because KMnO4 is a good oxidizing agent, it is going to liberate oxygen when it reacts with H2SO4. The reaction is given here, K2SO4 plus MnSO4 plus water plus 5 nascent oxygen, or we write it as 5/2 O2. Now, if that was the case with hot concentrated acid, what happens in cold concentrated H2SO4? The reaction results in formation of KHSO4, Mn2O7, manganese heptoxide and water. No oxygen is released. Manganese heptoxide is a very unstable compound. It decomposes violently with explosion to give MnO2 and then alone it releases oxygen. So finally we came to the conclusion that KMnO4 with concentrated H2SO4 under hot conditions releases oxygen instantly, and with cold condition or in cold concentrated H2SO4 It gives first manganese heptoxide and then that reacts violently to give manganese dioxide and oxygen is liberated. With KOH, it liberates oxygen but the reaction is very slow. Again, manganate is formed from permanganate. Now, this manganate will react with water and finally form MnO2 and again give me KOH and nascent oxygen is released. What about the reaction of KMnO4 in water? It dissolves in water, we said, but it also forms MnO2 and gives out 4 OH ions. So, now we can see that MnO4 minus, that is KMnO4, needs 3 electrons to form MnO2 and liberate hydroxide ions. What about if KMnO4 is heated? On heating, KMnO4 releases oxygen and forms potassium manganate and manganese dioxide. The permanganate reacts with H2O2 to give manganese dioxide and oxygen again. Now, KMnO4 reacts with H2O2 under acidic conditions as well as basic conditions. Under basic conditions, the reaction is slow. Under acidic conditions, the reaction is very fast. You can see here the products are also different. With H2O2, under basic conditions, you are getting MnO2, oxygen and water. H2O2 is now acting as a oxidizing agent. It has reduced Mn plus 7 to Mn plus 4 and itself has got oxidized. So, it is acting as a reducing agent because itself is getting oxidized to water and oxygen. If the medium was acidic, then the reaction between KMnO4 and H2O2 will give products as KMnO4 plus H2SO4 plus H2O2 giving me 3 oxygen. So, in both cases we get oxygen, but in the first case under alkaline conditions we had MnO2, in acidic conditions we had MnSO4, and it is clear that MnO4 minus have oxidized H2O2 to oxygen gas. Reduction has taken place from Mn plus 7 to Mn plus 2. That's all. That was the big difference in the two reactions. In one case we had MnO2, in the second case we had MnSO4. MnO2 under alkaline conditions and MnSO4 under acidic conditions. The reagents are H2O2 and KMnO4. Here the reactants are H2O2 and KMnO4. Reagent is H2O2. Here again the reactants are KMnO4, H2SO4 and H2O2. Now, in presence of sunlight, does KMnO4 show any reaction? Yes, it decomposes to MnO2, especially in aqueous solution, and releases oxygen. And the reaction can be easily shown like this. KMnO4 plus water giving you KOH plus MnO2 plus 3O2. So, you will find a solution of KMnO4, if you keep it for some days out on the sun, it will appear brown and not purple as we expect. That brown color is due to formation of MnO2. KMnO4 reacts with other compounds also in acidic as well as basic medium. Now, with Ki, you will find in acidic medium it liberates iodine, but in basic medium it forms KiO3. That is unique. How does this happen? This happens because H2SO4 is a strong oxidizing agent, and under neutral conditions or basic conditions, KMnO4 is a very weak oxidizing agent. So, under acidic conditions with H2SO4 and KMnO4, we are having strong oxidizing conditions, but not under neutral or basic medium. So, that is why Ki would not give me iodine in basic conditions, but it will give me KiO3. Next, we see the reaction with FeSO4. In FeSO4, you can again study the reaction in stepwise. It is like this. First, FeSO4 gets oxidized by H2SO4 in presence of the nascent oxygen liberated by KMnO4, and you get Fe2SO4 3. Then, there are 5 nascent oxygens left. We have used only one. So, multiply the reaction by 5, the whole equation, and then add. You will get 5 Fe2SO4 thrice. Okay, it should have been 5 Fe2SO4 thrice and 5 water in the second reaction with 3 water in the above reaction, that makes it 8 water total. So now the question is, why is KMnO4 so active as an oxidizing agent in acidic medium?